Now let's get some practice using the quadratic formula. Remember, the quadratic formula gives us a way to solve quadratic equations like these without having to do algebraic manipulation. All we need to know are the coefficients of our quadratic equation, because then we can plug them into this formula. X equals the opposite, or negative b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So as long as we know a, b, and c, which come from our equation, then we can just put them into this formula and we should be able to find x. So a, b, and c are just the coefficients in our quadratic that we're looking at. So in this case, for this first example, a would be 4, b would be 4, and c would be 1. So once we know that, we can go back to our formula and we can just put that in. So we get that x is equal to the opposite of b, so negative 4, plus or minus the square root of b squared, so 4 squared, minus 4 times a times c, all over 2 times a. Now we just have to do some arithmetic to simplify this. So we get negative 4 plus or minus, we know 4 squared is 16, then we have minus 4 times 4 times 1, so minus 16, all over 2 times 4 is 8. Now notice in the next step, if we want to simplify what's inside the square root, 16 minus 16 gives us 0. So we get negative 4 plus or minus, then the square root of 0 is 0, all over 8. Now it doesn't matter whether we're adding 0 or subtracting 0, it's going to be the same thing, right? So what we're left with is negative 4 over 8, which we can simplify to negative 1/2. So this is our only solution for this quadratic, and this actually tells us that that is already a perfect square. So if we had tried to factor that, if we could have found a way, then it actually would have factored to become a perfect square. We actually could have figured that out before we even started using the quadratic formula. We could use what we call the discriminant, which is just this part here inside the square root. So we could have taken b squared minus 4 times a times c, and notice that that was 0. That tells us that our quadratic equation that we're trying to solve only has one solution. Okay, let's look at this second example now. So notice there's no coefficient out in front of my x squared term. I can always put a 1 in there to be my a. Anytime I don't have an explicit coefficient given, it just means there's a 1. Then notice that b is not just 7, but it's actually minus 7 or negative 7. And my c is going to be negative 12. So those negative signs are going to come along with b and c. So let's put it into the formula. So x equals the opposite or the negative of b. So negative negative 7 would give us positive 7. Plus or minus the square root of negative 7 squared minus 4 times 1 times negative 12, that's all under the square root, all over 2 times a, or 2 times 1. Okay, so let's go through and simplify this now. So we have 7 plus or minus negative 7 squared is 49, and then I have negative 4 times 1 times negative 12. Well, that's going to be plus 48, since I have a negative times a negative, and on the bottom we have 2. Now I need to add 49 and 48. I can either do that in my head, or I can do it on paper, either way. So I get 7, and then I get 9, so it's 97. So we get 7 plus or minus the square root of 97 over 2. Now if we think about the square root of 97, we know that the square root of 100 is 10. The square root of 81 is 9. So the square root of 97 is going to fall somewhere between 9 and 10, but it's not a number that we necessarily know off the top of our head. So we can actually leave our answer like this. And just to make it more obvious that we do have both solutions, we do have two solutions here, I'm going to rewrite them this way. So we have x equals 7 plus the square root of 97 over 2, and also x equals the square root of 7 minus the square root of 97 all over 2. So don't be fooled by that plus or minus symbol. It really does stand for two separate solutions to the equation. And more times than not, when you try and solve a quadratic, unless it's one that's been nicely formed so that it comes out nicely, we're going to end up with an answer that looks something like that. Okay, let's practice some more. And notice, in this example, what's under the square root, or the discriminant, came out to be a positive number. So we got our two solutions. Okay. Let's look at now x squared plus 3x plus 4. So again, we don't have an a, but we can write it in. So that's a 1, b is 3, c is 4. So let's go ahead. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's go further and simplify. So I get 3 squared is 9, then I have minus 4 times 1 times 4, so minus 16 all over 2. And if we keep going, if we subtract, we get negative 3 plus or minus the square root of negative 7 over 2. Now, looking at this, it seems we have a problem. The square root of a negative number is not a real number, and we're only talking about real numbers right now. So there are actually no real solutions to this quadratic because I got that negative 7 inside the square root. That's going to make it so both of my solutions are imaginary, which we're not worried about now. So we're just going to say that this has no real solutions. And again, we could have known this ahead of time by using the discriminant, the b squared minus 4ac, and noticing that it was a negative number. So if that's negative, there are no real solutions. If it's 0, there's only 1. And if it's positive, like it was here, we get 2. Okie doke. Let's look at this one now. So again, we have a is 2, b is 3, and c is negative 2. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now let's simplify. So 3 squared is 9, minus 4 times 2 times negative 2 is actually going to give me plus 16 because I have a negative times a negative, and that's all going to be over 4. So if we keep going, we can take the square root, and it's now the square root of 25. Well, conveniently enough, the square root of 25 we know is 5, right? So I can just put that right in for the square root of 25. And now, at this point, we should be able to get two answers that are either just numbers or just fractions without the square root in them, since we actually had a square root that we knew. So one of my options is that x is equal to 3 plus 5 over 4. Sorry, negative 3 plus 5 over 4. So that will be 2 over 4, or 1/2. My other possibility is that x is equal to negative 3 minus 5 over 4. So that's going to be negative 8 over 4, which is negative 2. So there are our two possibilities, our two solutions. So this one came out nicely since we knew the square root. Now let's look at one that looks a little bit different. So we want 4x squared minus 3x plus 1 is equal to 2. Now this one is different from all the other examples we've looked at because it's not set equal to 0. It's set equal to 2 in this case. But notice that if I moved that 2 to the other side, my c value would actually change. Right now it looks like it's 1, but if I move the 2 over, it would be negative 1. So I need to make sure that I'm using this in the right way, that the formula is going to work, because it won't work for both c values. So what I need to do to be able to use the quadratic formula is make sure that my quadratic is set equal to 0. So I need to move this 2 to the other side. So I have plus 1, and then I'll subtract 2, so I get minus 1. And if I subtract 2 from the other side, it'll be 0. So there's just one extra step for this problem, or any problem like this, where we have to get everything to the one side so that it's set equal to 0. Now, we just have that a is 4, b is negative 3, c is negative 1, and we can go ahead. So we get x equals the opposite of b, so that becomes plus 3, plus or minus the square root of negative 3 squared minus 4 times negative 1, all divided by 2 times 4. Okay, let's keep going. So we get 3 plus or minus, and then negative 3 squared is 9, minus 4 times negative 1, 2 negatives make it positive, so that's plus 16 over 8. So now, notice that I'm going to get a 25 in my square root again. So again, just like I did over here, I can replace it with a 5 because we know that square root. So I have 3 plus or minus 5 over 8. So we can find our two solutions. One will be x equals 3 plus 5 over 8, which is just 8 over 8, or 1. And then the other would be 3 minus 5 over 8, or negative 2 over 8, which is negative 1/4. So there are our two solutions for that problem. And I promise that it's not always going to come out to the square root of 25, and that's not the only one we're going to know. It just happens to be the easiest one to make happen with small numbers. Okay, one more example. So let's take negative x squared plus x minus 6 equals 0. So notice that I don't have an a as of right now. I just have a negative times my x. Well, that means really negative 1 times x. So a is negative 1, and then just like before, we said we can put in a 1 as a coefficient if there isn't one there. So b is also going to be, a is negative 1, b is positive 1, c is negative 6. So let's go ahead. So x equals the opposite of 1 plus or minus the square root of 1 squared minus 4 times negative 1 times negative 6 all over 2 times negative 1. Actually, this should be a plus 6. So c is going to be positive 6. Otherwise, we're actually going to get a negative number in here. So if that had been a negative 6, we know that since this would be negative, there'd be no real solution. But we want real solutions this time, so we're going to use a plus 6. Okay, so we get negative 1 plus or minus 1 squared is 1. Then we have minus 4 times minus 1. So plus times 6 give us 24. So we get, again, the square root of 25 in there. So we can put in a 5. So negative 1 plus or minus 5 all over negative 2. So our two solutions would be negative 1 plus 5 over 2, which is 4, should be a negative 2, over negative 2, which becomes negative 2. Or we get x equals negative 1 minus 5 over negative 2, which is negative 6 over negative 2, or positive 3. So there are our solutions.